The following is the video solution from JSDT Solutions. Question 7.1 says, at what annual percentage interest rate compounded quarterly should a lump sum be invested in order to double in 6 years? Okay, so we are investing an amount and we're going to have it double in 6 years. So this is compound interest growth. And the formula looks like this. It says A is equal to P multiplied by 1 plus I raised to the power of N. And the A value is the amounts that we get after the investment has grown. And we can see that they say that it should double. So we can just assign values to this. Since the end result must double, let's say that the invested amount is X. And so the accumulated amount would be 2X. So we're saying that 2X is equal to, and our principal amount is the investment, the initial one, so that is X. And then 1 plus the interest is what we're trying to find out. At what annual percentage interest rate, okay, compounded quarterly. But that's the thing, it's compounded quarterly. So we know that when we have our interest, we're going to divide it by whatever compounding it is. So in this case, we'll say I divided by quarters, that is going to be over 4, raised to the power of N. So that's going to be, the years is 6 years, but remember that this is compounded quarterly, so we need to have this in quarters. So that's going to be 6 multiplied by 4, so we can have quarters. Okay, and what we're trying to find out is the value of I. So we can straight away move on to getting rid of X. So we can divide both hand sides by X, and that's fine in this case because you know that X is not 0, okay? For the money to have doubled, it couldn't have been 0. So this 2X divided by X is 2 is equal to, and those cancel, and we have 1 plus I over 4, and 6 times 4 is 24. So now we can get rid of that 24 by finding the 24th root of both hand sides of this equation. And so we can just leave this as the 24th root of 2 is equal to, and that would break open because they are the inverse of each other. So that is 1 plus I over 4, and then transpose the 1. So that is again the 24th root of 2. Then that's minus 1 is equal to I over 4. And finally, we can get rid of this 4 by multiplying both hand sides of the equation by 4. So to find I, we're simply saying 4 multiplied by the 24th root of 2 minus 1. And let's find out what our answer is. So I in decimal form is 0.117208. And then we have to take that answer and multiply it by 100. And when we do that, our final answer for I is, and we're just going to have to show them here so that it is a rate. So it's going to be 11 point, and that's just going to round down to 72. So there we go, 11.72%, and that is our answer. Question 7.2 says, Michaela buys furniture to the value of 10,000 Rand. She borrows the money on the 1st of February 2023 from a financial institution that charges interest at a rate of 9.5% per annum compounded monthly. Okay, so that's the interest and that's the compounding. Michaela agrees to pay monthly installments of 450 Rand. The loan agreement allows Michaela to start paying equal monthly installments from the 1st of August 2023. Okay, so let's just look at this as a timeline. So first, Michaela gets a loan. She wants to buy furniture worth 10,000. So that is the full amount that she's going to borrow. Okay, so she takes out a loan on that amount on the 1st of February 2023. And then they're telling us that she's going to start paying for this on the 1st of August 2023. Okay. They also give us the interest and the amount that she's paying every month. The first question is to calculate the total amount owing to the financial institution on the 1st of July 2023. So that means that on the 1st of July, a month before she starts paying, because she's going to start paying here, this is where that present value amount, the amount that she owes, is going to be determined. So we're going to have to look at how many months she has missed. Okay, so this is the 1st of July. So this is following the normal procedure of present value and how loans are paid. You borrow money and you start paying the month after. So we're going to determine her present value, the loan amount, and then she starts paying a month after. Okay, so from 1st February to the 1st of July, how many months has been delayed? That will be exactly 5 months because March, April, May, June, July. Okay, 5 months. So it means that this 10,000 that she borrowed, it's going to grow for 5 months. And so to allow it to grow, we're going to use, because this is compounded, we're going to use the compound growth formula. Okay, which again looks like this. And we're just going to say A is equal to, and we'll grow in 10,000 Rand. I'm going to say 1 plus, and the interest is 9.5% compounded monthly. So that is 0.095 over 12, and then raised to the power of 5 months. Okay, so we don't have to say times 12 in this case because this is already in months. We're not converting. Okay, so let's see what that gives us. And the amount that it grows to is 10,402.15. And that is our answer. Question 7.2.2 asks us, how many months will it take Michaela to pay back the loan? So how long is it going to take her to pay back the loan? We have all the information we need right now. And if they're asking how many months, they really want us to just find the value of n. Now, this is the payment of loan, so we're going to use the present value formula, which looks like this. So the present value amount, this represents the amount that is owed at this point in time. Now, right now, Michaela owes this amount that we just found. She owes this over here. So that is what we're going to put in place of the present value. And don't worry, you can put down the rounded off amount since this is an actual value that they asked us for. So in place of present value, we put in this 10,400 and then it's equal to an X. X is the monthly installments that she's paid. They told us that she is going to be paying 450 Rand as her monthly installment. So she's paying that every month, 450. And then 1 minus 1 plus. The interest is still the same, of course. It is 9.5%, so that is 0.095 over 12, and now raised to the power of. So remember that they're asking us how many months, so that's what we're trying to find out specifically. We'll say negative n. Now, I'm not going to multiply by 12, and here's the thing. We're trying to find out how many months, not how many years. Notice how whenever they give us the years, so, for example, if they said it's going to take her 8 years to finish this loan, to complete this loan, then we would say 8 multiplied by 12 so that this is converted into months. Now, the reason we don't have to multiply by anything right now is because this would have given us the total months, okay? That would have given us the months. So, instead of multiplying anything by 12, you might as well just leave it like that because like this, it will give you the total months. The only time it will be necessary to multiply n by whatever compounding you have is when you're trying to find out how many years, for example, and it was compounded in months, because then you're going to still have to divide by 12 to find out how many years. Okay, and then this goes all over the interest, which is still 0.095 over 12. Okay, so all we're just trying to do here is to get to this point. Okay, let us simplify. So when simplifying this, I'm going to try to avoid decimals. So let's leave this as 10,402.15. And then we're going to get rid of this denominator. So since this is a denominator, to get rid of it, you can multiply both hand sides by this number, right? And when we do that, what you do on this side, you have to do on this side as well. So we'll also multiply this side by it. And what's going to happen is over here, it would cancel. But over here, it will be multiplied by it. So this changes to this multiplied by 0.095 over 12. Okay, so at this point, the denominator is gone. So with this one, we're actually going to work with decimals at some point, but it's fine. And then we'll have 450 and everything in here. Okay, so it's going to look like that. Now, at this point, the next problem would be the 450. So to get rid of that, we can divide both hand sides by 450. And so it cancels here, but it's going to be on this side. So you can keep just writing that in that format, just so that we don't lose anything. We don't accidentally round off or, miss a number. Okay, so it looks like that for now. And then we have 1 minus and 1 plus 0.095 over 12 raised to the power of negative n. Okay, so at this point, you see that we have the number that is the base because it's carrying the exponent. But do you notice that this is negative? So to make it positive, we can transpose it. So move it over to the left-hand side. And now it's going to be 1 plus 0.095 over 12, but it's positive now. But the n, of course, will still be negative because this is an exponent. And this will simply be equal to what's left on the right-hand side is the 1. And we can transpose everything that is here. So we're taking this over and we're going to say minus all of this. Okay, so this is what we have. And at this point, we can start calculating. So you can put that on the calculator and find out what that gives you. And all of that gives us this, which we will not round off yet. So it's 0.816992, and that continues. And for this one, we can just leave it like this. That's fine. So it's 1 plus 0.095 over 12 raised to the power of negative n. Now we have the point where we can actually find the exponent using log. So we'll make the exponent the subject, negative n is equal to, and this is log, and our base is this number over here. So that is 1 plus 0.095 over 12. And then the answer that we get is this. Now, in place of this number, we're going to say aunt, just so that we don't lose any decimal. Okay, so this is negative n is equal to, and let's go ahead and find this. Okay, so on your calculator, it's going to be recorded in aunts. So you might as well just go log and then put down that base, which is 1 plus 0.095 over 12. Then I'll close that bracket. And then in place of that, I'm going to put down aunts. Okay, so I'm going to use that aunts button. So aunt, and there we go. That's our full answer. So it is negative 25.6315. But of course, we are going to multiply both hand sides by negative 1 or divide by negative 1 as well. And that will give us our answer as a positive number. So it is just 25.63, right? Rounded off to 2 decimal places. Now, we would need to go back to the question just to see exactly what they were asking for, and so that we can understand what answer we should take. The question is, how many months will it take Michaela to pay back the loan? So here's the thing about this. But if we say that n is equal to 25 months, then she's not going to be done with this loan because she still has this 0.63 to go, okay? 0.63 months. And that is still money owed. So instead of saying 25, we'll say that she has 26 months left to go. And that is our answer. Question 7.2.3 says, what is the balance of the loan immediately after Michaela has made the 25th payment? Okay, so let's understand what they mean by that. You see, to find the balance of the loan, we can still use the present value formula. But you will notice that with the present value formula, we have a negative n. There's a reason it is negative. The n is going to tell you how many more payments still need to be made. You can see this in the previous question. You see how the question was, how long will it take her to finish paying off this loan? Okay, so how long will it take her? How many months will it take her to complete the loan? And we see that it takes 26 months. This tells you exactly how many months more you have to complete that loan. So if we're trying to find out what she will owe immediately after the 25th payment, right? So let's say this was the 25th payment. We saw that here when we found the value of n, when trying to find out how long it's going to take her to complete this loan, we see that we got 25.63. Now, it's that 0.63 that we're referring to there. At the 25th payment, she would still have 0.63 payments more to go. Technically, 0.63 months to go. So in order to find this, we can use the present value formula again, but in place of n, we're going to put 0.63 because this would be the payments left to go after she has reached the 25th payment. Immediately after the 25th payment has been paid, she has 0.63 payments left to go. Okay, so just remember that n tells you the amount of payments you have left to make. Okay, so let's put down the present value formula, and we are trying to find the present value. Okay, we're trying to find out how much will she owe immediately after the 25th payment. So this is left open. And then we know that X, she's paying $450 every month, right? That is $450. And so we'll say $450 and then open bracket 1 minus 1 plus 0.095 over 12 raised to the power of. Now, instead of rounding off here, we can actually keep those decimals, which we still have recorded on the calculator. So that is negative 0.6. 3, and that just went on to 1.5, and we'll just do that just so that it shows that we didn't round off yet, because we're trying to find out exactly how much. Let's not cut out decimals in this case. And then we close that bracket, and then we put this all over the interest, so that's 0.095 over 12, and let's go ahead and put that in and find out what we get. Okay, now on your calculator, you'll still have this. So just to get that negative 0 point, because we just wanted to stay negative, okay, it will be easier like that. So we don't have to apply a negative. You see, it's negative 25.63, and then that keeps going. So just add a 25 to it so that you can get the 0.63, okay? So that is equal to, and then we'll just say plus 25. And there we go. So that's what we want. And we're going to put that in place of that exponent. Just make sure not to say negative of that because it's already negative. Okay, so in place of the exponent, we'll just say aunt. And there we go. So there's our answer. The amount that she'll owe immediately after the 25th payment is exactly 282 Rand. And then we'll just round that up to a 6, so 0.36. And there we go. And that's how much she's going to owe exactly after the 25th payment. And that is it for the financial math section of this paper.